So a rough sketch of these things going to look like this. Hopefully for us, that most of the time when we're given questions, they give us the graphical representation of it. So it's something that you shouldn't worry about. But now, every once in a while, now you'll see why we had to learn the four-sided figures properties last year in grade 10. For example, they say this one here is a parallelogram. Now, what are some of the properties of a parallelogram? Properties of a parallelogram is that we say this one is going to be parallel to this one. And then this one here is going to be parallel to this one here. Not only are they parallel, this one is going to be equal to this one. This one is also going to be equal to this one. So those are properties of a parallelogram. But the most important property of a parallelogram, one that we're most likely going to use in analytical geometry, is the one of parallel lines. This line is parallel to this one, and then we will get to that with what does it mean when we say two lines are parallel. But we did touch on it last year. Now, the one that we're going to use for midpoint is the following. If I draw a line from D, and then it goes to B, and then I draw another line from A to C. Now, what we know is this, where they intersect here, they are going to be equal. And then we call this the diagonal bisect each other. So the pieces inside they are going to be cut into equal parts. So if they say to you, show that the diagonals of a bisect each other, they mean you need to calculate. In other words, like this is me showing learners to say, okay, we've calculated the midpoint. We know how to calculate the midpoint. But the question of a midpoint is not always going to ask to say, calculate the midpoint of so and so. Sometimes I can say to you, show that this thing here is a parallelogram. How do you show what something is a parallelogram? We use the midpoint. So we're going to say that we have D, B. If you have DB, you're going to use the coordinates of D and the coordinates of B. Let's take the coordinates of B and the coordinates of D. So we have coordinates of B, which is going to be equivalent to 3 is to minus 2. And then I have the coordinates of D, which is going to be minus 2 and 5. Now I'm going to calculate the x of the midpoint here. So I'm going to say x at the midpoint is going to be given by x1 plus x2 divided by 2. And then I'm going to say y of the midpoint is going to be given by y1 plus y2 divided by what? By 2. Now between P and D, which one comes first so that you can name them? So we'll say this one is x1. This one is going to be. Then here you have x2, here you have what? y2. Okay, then from here it means our x1 is 3. So we say 3 plus minus 2 divided by 2. And then for this one, you will have y of m, which is going to be given by y1. What is our y1? Minus 2 plus, what is our y2? 5 divided by 2. And then from here onwards, if you type this in your calculator, you are going to get 1 all over 2. And then y of m, you are going to get 3 all over 2 again. And then you say m. Let's call this one m1. M1 is for GB. M1 is going to be, if we say this one here, if you consider this one to be m1, and then we say m1 is actually going to be equal to 1 all over 2, and it's 3 over 2. Okay, so we have 1 over 2 and 3 over 2. The next thing that we're going to look at is A and C. So if I look A and C, why I didn't take A and D? Because I'm proving which the diagonals bisect each other. Diagonal bisect each other, it means which way they intersect. They need to have equal midpoints. So let's check the other one of AC. So if we take A, we have 2 is to 3. And then if we take C, we have minus 1 is to 0. And then again, we say X at M is going to be X1 plus X2. Y of M, Y1 plus Y2 divided by 2. Y of the midpoint is going to be given by, we choose this one to be X1, Y1, X2, Y2. Okay, based on how you chose, what is our X1? It's 2 plus. Huh? I'm doing? I did your 1. 2. Huh? I wrote what? Oh, I wrote y midpoint and then it's supposed to be x midpoint here. Oh, okay. So here it's 2 plus minus 1 all over 2. And then if you type this in your calculator, it gives you 1 all over 2. And then this one here, you're going to have y1, you said it's 0 plus, it's 3. It's 3 plus 0 divided by 2. And then you get 3 all over 2. Now it means put your m here, you also get, let's call this one m2. M2, you got it as 1 all over 2 is 2, 1 is 2, 3 all over 2. Then it means to this thing here, the diagonal bisect each other because, yes, it helps if you do that, but it helps you if you do that one. And so if we look at the following, then we can come and do this one in a minute. We're going to try this one here. Looking at the following,